In this video, we're going to learn about transition matrices. A transition matrix is a square matrix that describes how things move between different categories or states from one time period to the next. Remember that a square matrix is one that has the same number of rows as columns. Each column of the transition matrix represents a current state. The entries in that column tell you the proportion of things expected to move to each state in the next time period. There are two important properties of every transition matrix. First, all entries are between 0 and 1. They represent proportions, not counts. Second, each column must add to exactly 1. Everything must go somewhere. We don't lose things and we don't gain things. The second matrix we need is the state matrix, Sn, which records how many things are in each category at time period n. To find the next state matrix, we just multiply T by our state matrix. This means we can find any future time period by repeatedly multiplying by T. That is, our state matrix in time period n will be equal to our transition matrix T to the power of n times our initial matrix S0. On your CAS, this is the most efficient way to calculate state matrices for larger values of n. That is, we type in our transition matrix, we put it to the power of n, and then we multiply by our state matrix. Now let's consider a question so we can see how the transition matrices work. In this example, a wildlife reserve monitors the location of a koala population across 3 zones: forest, F, grassland, G, and scrubland, S. The transition matrix T below shows the proportion of koalas expected to move between the zones each month. So remember, each column represents our current situation. So I'm going to write current here. And then each row represents our next period. What that means is that 30%, 0.3, of koalas are currently in the forest and will move to the grassland, G. So we're going from F to G. Or we could say that 20% of koalas currently in scrubland are moving to G, grassland. Next, we can see our initial state matrix, which tells us that initially 80 koalas are in the forest, 50 koalas are in the grassland, and 30 koalas are in scrubland. Sn represents the number of koalas in each zone n months after monitoring begins. So now let's look at some questions. The first question, how many koalas are being monitored in total? Well, remember that we had 80 in our forest, plus we had 50 in our grassland, and then 30 in our scrubland. Adding those numbers up gives us 160 koalas. Next, we want to calculate S1, the state matrix after 1 month. Well, to calculate S1, we need to do our transition matrix multiplied by S0. So we need to put that into our calculator. So remember, our T matrix was 0.5, 0.2, 0.3. On the next line, 0.3, 0.6, and 0.2. And then we have 0.2, 0.2, and 0.5. We then multiply that by our S0 matrix, which was 80, 50, and 30. Well, putting that into our calculator, we end up with our S1 matrix, which is 59, 60, and 41. What that tells you is that we're expecting 59 in the forest, 60 in the grassland, and 41 in the scrubland. Okay, part C. How many koalas are expected to be in the grassland zone after 2 months? And we're going to round our answer to the nearest whole number. Well, in that instance, what we can do is we can do S2 will equal T squared times S naught. Or you could do that S2 is equal to T times S1. So that is, you could take your initial matrix and multiply it by T squared, pre-multiplying that is, or you could multiply your S1 matrix, so that is, look at how many koalas are in each location after 1 month, and then multiply that by T. Okay, so applying that, we get our matrix, and it's going to again be 3 rows with 1 column, but we only care about one of those entries. And the one we care about is our second row, this one here, because that is the grassland number. And so putting that into our calculator, what we get is we get 56. The other numbers are irrelevant here. Okay, part D. What proportion of koalas currently in the scrubland zone are expected to move to the forest zone next month? Well, for that one, we can just read off our T matrix. So looking at our T matrix, we can look here. We want to know who is in the scrubland zone. So that is looking at our third column. Moving to the forest zone, so it's going to be this number here, 0.3. So our answer to part D will be 0.3. And then lastly, the reserve ranges become concerned when the number of koalas in the forest zone first falls below 55. After how many months does this occur? Well, this one is a CAS question. So what we would do is we would just keep applying our T matrix until we get to 55 or below 55 for in our first row. So remember, it's the forest. So the forest zone, first below 55. And by doing that, what we end up with is we get month 3. And we end up with 52 koalas there. So that's transition matrices. If you need help or have further questions, please reach out.